Okay, so today's notes are on systems of inequalities. First section from Unit 3. Our content objective is to solve systems of linear inequalities, and our language objective is to use the correct terminology to describe solutions of systems of inequalities. This ties really closely into what we left off with in Unit 2. So we're going to be graphing linear inequalities, as is mentioned, and this time, though, we're talking about systems. So our first example asks, what is the solution of the system of inequalities? 2x minus y is greater than or equal to 3, and y is greater than or equal to negative 1/2 x plus 1. So what this means is when you have a system of equations, a system of equations is a set of two or more equations that make up a set or a system. So we have a system of inequalities, so we have two inequality or linear inequalities here. So the solution is going to be the section that makes both of these inequalities true. So what this is asking ultimately, or what this question when it says what is the solution of the system of inequalities, it's asking what values of x and y make both inequalities true. So it's asking what values of x and y make both inequalities true. So the way we're going to approach this is by graphing them. So we're going to graph them and see the section that would make both of these true. In order to do that, we're going to start by rewriting the equations in slope-intercept form so we can graph them. So we're going to rewrite equations so both are in slope-intercept form. So the second one is already in slope-intercept form. The first one is not quite yet. So I have 2x minus y is greater than or equal to negative 3. I'm going to subtract 2x from both sides. I get negative y is greater than or equal to negative 2x minus 3. And then I divide everything by negative 1 to get y by itself. When I divide by negative 1, I have to remember to flip my inequality. So it's going to be y is less than or equal to 2x plus 3. So when I rearrange this, I end up with y is less than or equal to 2x plus 3. And then I'm just going to carry down my other equation, or inequality, sorry, from my system set. And I have y is negative 1/2 x plus 1. Now I'm going to sketch both graphs. To do that, I need to remember to keep track of solid and dashed lines since these are inequalities. So in this case, they're both solid since they both have that equals to line. That will not always be the case, so I need to make sure I pay attention to that. And then I also need to pay attention to shading, if I'm shading above or below. So this is also going to be important. That's why it's going to be so important when you're rearranging to remember to flip the sign if you need to do, or the inequality sign if you need to do that, because that's going to make or break your solution set. So now that I've reminded us what we need to pay attention to, I'm going to go ahead and sketch this graph. Should be good. I have my x-axis, I have my y-axis, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I have my grid. I'm going to start by graphing this one. So I'm starting at positive 3, and I have a slope of positive 2, so I'd go up 2 over 1, but since I don't have enough room up here, I'm going to go the other way, but make sure it's a positive slope. It's going to be a solid line, so I can just connect the dots with a solid line. Since it is less than, I'm going to shade below. So anything below this line will be in my solution set. So presumably if this kept going up, I could keep shading under it. Sorry, I'm not showing you the whole graph. I could keep shading under it, but I'm shading lightly. You'll see why in a second, but make sure when you shade this initially, you shade it very lightly because it's not all going to be part of our solution set. Only a section of it will be. So then the next part I have y is greater than negative 1/2 x plus 1. So I'm going to go to plus 1. And I have a slope of negative 1/2, so I know it goes down from left to right. So I go down 1 over 2, down 1, and probably be around here. I can go the other way. And then again, it's going to be a solid line since it has the equals to line. This time it's greater than though, so I'm going to shade lightly above. So I'm shading above this time for that line. At this point, hopefully you've noticed that we have 4 different sections, 3 of which are shaded, but only 1 of which is shaded by both inequalities. So this double shaded area is our solution set because these are all the values of x and y we could plug in to our inequality and have them still be true, to have these inequalities still be true when we plug in any of these values. So I want to emphasize that as even one of our steps. The solution is the double shaded region. So this is our solution set. So now that I know this is the solution set, I can go back and shade this a bit darker than the other sections since this is my actual answer. Sorry, my dog's barking. But this is our solution set for this problem. Any of these values should work when plugging into our inequalities to see if they're true. So what we're going to do now really quick is do a test point. So I'm going to check if shading is accurate. With a test point. So I'm going to choose a point from this double shaded region. I'm going to choose this one right here. So I'm going to choose the test point 0, 2. And I'm going to plug it into both my original equations. So both of these original equations. So I have 2 times 0 minus 2 is greater than or equal to negative 3. And then I have 2 is greater than or equal to negative 1/2 times 0 plus 1. So these I'm plugging into my original inequalities again with my x and y values. So when I plug that in, I get 0 minus 2 is greater than or equal to negative 3. So negative 2 is greater than or equal to negative 3. That is true. Negative 2 is greater than negative 3. So that inequality is proven true. That one's all set. The second one, I'm going to do the same thing. Negative 1/2 times 0 is 0 plus 1. 2 is greater than or equal to 1. That is true. So again, both of these prove true. I've properly shaded. This is my solution set, this double shaded area. So write down any questions on that. I'm going to flip the page and go over another one together. So page going over another one. So this one I want to try as a quick check. And what I mean by that is I want you guys to try this on your own really quickly first and see if you can get it. And if you don't get it, then I will go over it in just a minute. But I want you to try it on your own, see if it makes sense. So what is the solution of x plus 2y is less than or equal to 4, and y is greater than or equal to negative x minus 1. So pause that. I'm going to go over, or try it out on your own. I'm going to go over it in just a second, but I'm going to start by making my graph here. Okay, so first thing I need to do is put these both in slope-intercept form. So this one's already all set, but I need to rearrange this one. So I have x plus 2y is less than or equal to 4. Subtract x from both sides, and I get 2y is less than or equal to negative x plus 4. Divide everything by 2, and I end up with y is less than or equal to negative 1/2 x plus 2. So I didn't show the work for that, but I showed the different steps. So I subtracted x from both sides, I divided all parts by 2, and I get y is less than or equal to negative 1/2 x plus 2. If you didn't get that, star that. I can show you how to do that in class, but that is this equation rearranged into slope-intercept form. So now I'm just going to graph my two equations. I'll start with the one I just rearranged. So I'm going to go to positive 2. I have a negative slope, so I'm going down 1 over 2, down 1 over 2. And then I can continue by going the other way. So I go up 1 over 2 this way, up 1 over 2 this way, and then up 1 over 2 this way. Those are not, my graph is not perfect since it's hand drawn, but bear with me. Since it has the equals to line again, I'm going to connect with a solid line. Ideally, it'd go straight through every point. And since it's less than, I'm shading below. So I'm going to again shade lightly below since it is not my final answer, but the first section that I will be needing to use in my solution. The next one has a y-intercept of -1. It also has a negative slope, so it's going down from left to right. So I can go down 1 over 1 this way, and then go up 1 over 1 the other way. Up 1 over 1, up 1 over 1. 1, 2, 3, 4, 5, 3. Okay, up 1 over 1, and then up 1 over 1 again. So this is my final line for that one. They just barely intersect up there. And I'm shading for this one above. So the other one shaded below, this one's shading above. So my double shaded region ends up being this section that seems almost between the two of them. So the double shaded region is that section between the two of them. And that is our answer or our solution set for that. We'll check it with a coordinate point or a test point. So test point is going to be 0, 0. So if I plug that in, I get 0 plus 2 times 0 is less than or equal to 4. And 0 is greater than or equal to -0 minus 1. So I end up with 0 plus 0, which is 0 is less than or equal to 4. That is true. And 0 is greater than or equal to -1. That is true. So both are true. I've accurately shaded and found my solution set. I'm all set. All right, we will also try some in class with some absolute values or absolute value graphs, but that's all for our notes today. Make sure you write down any questions, comments, or concerns you have on this stuff so we can go over it together in class.